Good evening, children.
Good evening, ma'am.
Good evening. I've shared my screen. Is it visible?
Yes, ma'am.
Yeah. So we stopped here in the last class. I don't remember if we completed this one. But this annotation says that I've explained till here. So if we haven't completed the answer, please check. Okay. So we need to continue from here. If Q 0, 1 is equidistant from P and R. So Q is equidistant from P and R. So we have Q and we have the points P and R. Q is equidistant from P and R. That means QP is equal to QR. Q is given by 0, 1. This is 5, -3. And this is x, 6. Find the values of x. So the condition here will be QP is equal to QR because it's given that Q is equidistant from P and R. Now this means that QP square is equal to QR square. Now we just have to use a distance formula to find QP. We have to use a distance formula and then square it. So which means the distance formula is square root of something, but QP square meaning you don't have to show the square root symbol. So work this and you should be able to get the values of x. Yeah, do that, children. Take down the question. Work this and tell me the values of x. Okay, so x is equal to plus or minus 4. Now we need to find, after finding the values of x, we need to find the distances QR and PR. But R has two addresses. So for QR, you need to take Q 0, 1 and R 4, 6. And also work when Q 0, 1 and R is -4, 6. I'll show you the answer on the next slide. So after finding the value of x, you can see here R is given by this because x is plus or minus 4. So R is given by x, 6, R. So it can be 4, 6 or -4, 6. So to find the distance QR, when Q is only one address, Q 0, 1. But R has two different addresses. So 4, 6, -4, 6. Find QR under both the cases. Then PR also in the same way. P is only one address, 5, -3, 5, -3. But R has two different addresses. So find PR under both the cases. Yeah, work this, children. So I'll just tell you one thing here. I've written 16 plus 25 straight away because subtract the x coordinates. So 0 minus 4. Subtract the x coordinates. 0 minus 4 is minus 4 and square it. So 16 plus subtract the y coordinates. 1 minus 6 minus 5 and square it. So plus 25. And add both the values with x2 minus x1 the whole square plus y2 minus y1 the whole square. So similarly here, subtract the x coordinates. 5 minus 4, 1. Square it. 1 square is 1. Subtract the y coordinates. Minus 3, minus 6, minus 9. Square it. Minus 9 is plus 81. And you have to add the two values. So plus 81. At 8:30, I'll be sharing a set of questions based on the based on based on the questions we have understood so far from this chapter. Yeah, done this one. Done, children?
Yes, ma'am.
Okay, thank you. Now find the values of x and y if the distances of the point P from A and B are 4 units. Find the values of x and y if the distances of the point P from A and B. That means P, the distance between P and A, the distance between P and B. See here, point P from A, point P from B. The distance of point A, the distance of point P from A and the distance of point P from B. P from A, P from B. So that means the distances PA and PB both are equal to 4 units. The distances PA and PB both are equal to 4 units. The distance of the point P, so this one point P, the distance of P from A and the distance of P from B. So that means P is equidistant from A and B. So PA is equal to PB and both equal to 4 units. Given this, you need to find the values of X and Y. So look at this. So we know that PA is 4 units. So PA square is 16. And then you know how to apply the distance formula. Using P and A, using the coordinates of P and A, you can find PA square. So that gives you an equation, a quadratic equation in X and Y. X square, Y square. Now PB is also 4 units. So find PB square is 16. And you know how to work this is equal to 16. This again gives you another equation in X square and Y square. Now place the equations one below the other. Place the equations one below the other and subtract them, because you know when you change the signs you can cancel. See, when you have two equations, you can add the two equations, you can subtract the two equations, you can multiply them, you can divide them. Do what will help you in that situation. I'm not saying that you do anything, you will get the answer. In some cases, when you add, you get the answer easily. In some cases, you'll have to subtract, sometimes multiply, sometimes divide. So when you have two equations, you can perform all the 4 mathematical operations with them. So in this case, when you subtract, it'll help you to get the value of X. So change the signs throughout. So cancels. 7 minus 7 is 0. So 6x plus 6x, 12x is 0. So x is equal to 0 by 12, which is 0. Now to find the, Sashank, your mic is enabled. Please disable your mic. Yeah, thank you. Yeah. Now the question is to find the values of x and y. So substitute x is equal to 0 in any one of the two equations. In any one of the two equations, substitute x0, you will get the value of y. And so here we have two values for y, plus or minus root 7. Right on, children? See, you can also equate the two equations. You can say this one is 7. This one is also 7. So like 1 is equal to 2. This one is 7. The value of this expression is 7. The value of this expression is also 7. So you can even equate 1 and 2. 1 is equal to 2. So that means since the RHS is 7 in both, you can equate the LHS. So that means x squared plus 6x plus y squared is equal to x squared minus 6x plus y squared. So x squared gets cancelled on either side, y squared on either sides. Then 6x plus 6x, 12x is equal to 0, x is equal to 0. You can also equate 1 and 2. Done, children? Completed. Yeah, good. So the question is to find the values of x and y, given that P is equidistant from A and B, and the distance PA and PB, both equal to 4 units, is given to you. PA is equal to PB, and each distance is equal to 4 units is given to you. So when you work PA is equal to 4, you get an equation. PB is equal to 4, another equation. And on solving these equations, we get x. And on substituting, we get the value of y. Or here we get two values for y. I'll just cover the questions pertaining to the test today. We'll do all this. Yeah. Look at this question. The length of a line segment AB is 10. So AB is equal to 10. The address of A is given 2, minus 3. And the abscissa, that means the x-coordinate of B is 10. You need to find the ordinate of B, that is the y-coordinate. So this is simple. A is 2, minus 3. B is 10, y. We do not know the y coordinate of B, but we know AB is 10 units. The distance AB is 10 units. With this, you have to find the value of y. So AB is given, so which means AB square is 100. On solving, y is -9 or y is 3. Yeah, right on, children. So B can be 10, -9 or 10, 3. But to answer the question specifically, the ordinate of B, ordinate of B is -9 or 3. All right. Completed, all of you? All right, no response. There's the next one. Somebody still working?
Completed, ma'am.
Okay.
1 minute, ma'am.
Oh, yeah, sure.
Completed.
Yeah.
Completed, ma'am.
Very good. All right. The next one says the x coordinate of P is twice its y coordinate. The x coordinate of P, so there is a point P. The x coordinate of P is twice its y coordinate. So if the y coordinate is y, the x coordinate is twice this one, twice the y coordinate. So 2y. See, like consider this one. If this is 4, this one is 8. See, the x coordinate is twice the y coordinate. The x coordinate is 2 times the y coordinate. So that means if this is y, if the y coordinate is y, the x coordinate is 2y. So let P be given by 2y, y. If P is equidistant from Q and R, find P. So the same fundamental that PQ is equal to PR. So the condition is PQ is equal to PR. Because P is equidistant from Q and R, it means PQ is equal to PR. So PQ square is equal to PR square. Got this? So here, children, in this step, you can either expand, or we have used this idea earlier. We are trying to have this 2y minus 2 the whole square and this one on one side, so that it looks like a minus a square minus b square. This one has 2y here, 2y here. When you transpose 2y minus 2 the whole square minus 2y plus 3 the whole square. So it's like a square minus b square, which can be written as a plus b into a minus b. And then you take this one here. So y minus 6 the whole square minus y plus 5 the whole square. Again, a square minus b square, which is a plus b into a minus b. You can also expand. Without transposing, you can also expand this. You'll get the same result. Done, children?
Yes, ma'am.
Yeah.
Completed, ma'am.
Very good. Okay, so since it's given that the x coordinate of P is 2 times the y coordinate. Let the y coordinate be y, so the x coordinate will be 2y. So this is about the point P. Now it's given that P is equidistant from Q and R. That means PQ is equal to PR, which also means PQ square is equal to PR square. But now you know you have to use the distance formula without the square root symbol. And then you can either expand using the identities a plus b the whole square and a minus b the whole square, or you can transpose so that the left hand side and right hand side looks like a square minus b square. Which is further written as a plus b into a minus b on both the sides, and then further simplifying y is 8. So that means the coordinates of the point P are 2 into 8, 16 and 8. Check if the following points are collinear or form a triangle. So we know that when we have 3 points in a plane, only 2 cases are possible. When we have 3 points in a plane, either the 3 points are collinear, that means they can be connected by the same straight line, or they're not collinear. That means if they're not collinear, a triangle is formed. A triangle is a figure formed by joining 3 points in a plane or by joining 3 non-collinear points in a plane. A triangle is a figure formed by joining 3 non-collinear points in a plane. Because if the points are collinear, no triangle is formed. There are 3 points. To get the 3 vertices, there are 3 points. But since the points are collinear, no triangle is formed. If the points are not collinear, then you can connect them and get a triangle. So that's the heading. Check if the following points are collinear or form a triangle, meaning or not collinear, because only when they're not collinear, they'll form a triangle. So simply the heading is check if the points are collinear or not collinear. So this you'll work it yourself. I'll just explain how it goes. So you can see here. Yeah. One more thing is I have to tell you is now if the points are collinear, what's the check for collinearity? Earlier when we had that concept of finding area of a triangle using the coordinates of the vertices of the triangle. See here. So supposing A is given by some 2, 5, B some minus 4, minus 3, and C. Don't validate these points. I'm just taking something. Okay, something like this. So we have a formula using which we can find the area of this triangle using the coordinates of A, B, and C. But now that's removed from the syllabus. So then we have only one method. In your syllabus, we have only one method to check the points are collinear. So now we have the points A, B, and C. So you need to first find the distance AB, BC, and AC. Any order. Now supposing you get AB is 5, BC is 7, and AC is say 12. For example. Now what we know is if a triangle is formed, then the sum of any 2 sides of the triangle will always be greater than the third side. If a triangle is formed, the sum of any 2 sides of a triangle is always greater than the third side. It will not be equal to, it will be greater than the third side. So now if you add 5 and 7, you get 12. which is equal to the third side, 12. So in this case, no triangle is formed because it doesn't satisfy the condition that the sum of any two sides of the triangle is always greater than the third side, or the difference of any two sides of a triangle is always less than the third side. The difference of I think I'll just write that. You can make a note along with me because we are working this later. I'll just tell you how the answers go. So you can just make a note of all the questions and the two notes which I'm going to write now. I think to make it more interesting, I'll allow you to find AB, BC, and AC. Yeah, I think that'll be better than me showing the slides and explaining. Or if you find AB, BC, and AC for all these 4 cases. And then if you're able to proceed, fine. Otherwise, we'll see what to do. So for all these, it's easy to find AB, BC, and AC. That's easy to find. So find AB, BC, and AC for all these 4 questions. And if you can complete it, fine. If you can't complete it also, it's fine. We'll see how to complete it. Okay. So these are the things which we already know about a triangle. So this is the check for about a triangle, meaning that the sum of any 2 sides is always greater than the third side. The difference of any 2 sides is always less than a third side. Now the check for collinearity is if the points are A, B, and C, then the sum of any 2 of them should be equal to the third. Then the points are collinear. Finish writing this.
Yes, ma'am.
Yeah. So all of you carefully find, for all these 4, carefully find AB, BC, and AC. And leave some space. If you're not able to complete it, leave some space. We'll see it. I have the answers with me. We'll do it. So I can just give you a clue, like if you have, they can also be surds. Okay. So like you can have maybe the distance, is like one is root 8 units. The other is say like root 32 units. What's this? What is root 8, children? 2 root 2, right? And what is 32? 4 root 2. So the sum is 6 root 2, right? So 6 root 2 meaning 36 into 2, 72. So this may be 72 units. So if you get distances like this, if you get AB is root 8, BC is root 32, and AC is root 72. Okay. So supposing you get this. Or something like this. AB is equal to root 8. So root 8 is irrational. And you can write it as a mixed surd. Root 8 is a pure surd. You can write it as a mixed surd. So 2 root 2. Then supposing you get BC is equal to root 32. Again, it's a pure surd. You can write it as a mixed surd, 4 root 2. And AC, supposing is root 72. Again, it's a pure surd. You can write it as a mixed surd, 6 root 2. So now you see that AB plus BC. What is AB plus BC? AB plus BC is 2 root 2 plus 4 root 2, which is 6 root 2. What is AC? AC is also 6 root 2. You can add any 2. It's not that you'll have to add in the order. You can add any 2. You can check AB plus AC or BC plus AC or AB plus BC. Check anything, any sum you can check. So it's very visible actually. It's very visible that 2 plus 4 is 6 and 6 here. So you work AB plus BC and show it is 6 root 2, which is equal to AC, which is also 6 root 2. So since AB plus BC is equal to AC, the points A, B, and C are collinear. The points A, B, and C are collinear. So for these questions, I said find AB, BC, and AC. Yeah. Yes. I'll just tell you about the quadrilaterals. 1 second. Yeah. Now, say here we have check if the following points form a quadrilateral. If yes, give a special name to the quadrilateral formed. So now the definition of a quadrilateral is this. A quadrilateral is a figure formed by joining 4 points in a plane of which no 3 points are collinear. No 3 points are collinear. So quadrilateral is a figure formed by joining 4 points in a plane of which no 3 points are collinear, because it's not enough if you have 4 points in a plane. See, like we have 4 points in a plane. But now this one will not form a quadrilateral because these 3 points are collinear. So though we have 4 points, we are able to connect them and make a triangle only. Not a quadrilateral. Why? Because of the 4 points, 3 points are collinear. So they are connected by the same straight line, due to which we cannot get a quadrilateral, but only a triangle. That's why of the 4 points, no 3 points must be collinear. It's not enough if you have 4 points. Of the 4 points, no 3 points must be collinear. So supposing you have points like this. See, oh sorry. Okay, so somewhere, oh my God, why they always maybe here, oh here. Okay, so we have 4 points and you can see that no 3 points are collinear. So when you connect them in order, children, you should connect it in order. Okay, let me include that. A quadrilateral is a figure formed by joining 4 points and 4 points in order. You can just write in order in bracket, in order, because you cannot join like, you know, as we please. You can't say, yeah, see, I connected, I'm not getting a quadrilateral. You should not lift your hand while connecting. So see, if you start here, you should not lift your hand. Don't lift your hand. Now you're done. So quadrilateral is a figure formed by joining 4 points in order. Okay, that order is very important, in order. Okay, by joining 4 points in a plane of which no 3 points are collinear. So this is how we check if 4 points can form a quadrilateral or not. Okay, and we also know the properties of properties of special quadrilaterals. In a parallelogram, opposite sides are equal. In a rhombus, all the sides are equal. And if opposite sides are equal and diagonals are unequal, it's a parallelogram. But if opposite sides are equal and diagonals are also equal, it's a rectangle. Here, parallelogram, rectangle, rhombus, square. You can just remember like this, rhombus and square. I think I need to clear the slide, children. Just make a note of these. Make a note of this definition of a quadrilateral. I need to clear the slide to write something else. Done writing? Class, use the emoji. Raise your hand. Diliban, Florentina, Krishmi, Sashank, Raja, Danya, Prajit, Rakshita, Navya, Tanishka, Arjun and Ritika. Arjun, Ritika.
Ma'am, I keep raising my hand. It is not showing.
Okay, darling. Fine, fine. Got it. All right, children. Thank you, children. Yeah. Can I clear the screen?
1 minute.
Yes, ma'am.
Okay, yeah, sure.
Completed, ma'am.
Very good. Okay. So that's about when a quadrilateral can be formed, even if we have 4 points in a plane. So even though we have 4 points, in a plane, a quadrilateral can be formed only when of the 4 points, no 3 points are collinear. And also we must join the points in order. Okay. Now talking about parallelogram and rectangle. Okay. If opposite sides are equal, let me do it like this. Opposite sides equal. It can be a parallelogram or it can be a rectangle. But opposite sides equal, or 1 minute, I'll just put everything in one. Opposite sides equal, diagonals unequal. It's a parallelogram. If opposite sides are equal, diagonals also equal, then it is a rectangle. If all sides are equal and diagonals are unequal, it's a rhombus. If all sides are equal, and diagonals are also equal, it is a square. It's a square. So you'll have only these 4 quadrilaterals: parallelogram, rectangle, rhombus, square. So how do you check if you're given 4 points? If you're given 4 points A, B, C, D, and if you're asked to check if it forms any one of these 4 quadrilaterals. So when you have the points A, B, C, and D, you need to work AB, BC, CD, AD. Find all this using distance formula. Also find AC and BD. Now, if you see that all the sides are equal, then it is a rhombus. But if all the sides are equal and the diagonals are equal, then it's a square. If all sides are equal and diagonals are unequal, it's a rhombus. All sides equal, diagonals unequal, rhombus. All sides equal, diagonals also equal, square. If only opposite sides are equal, like AB is equal to CD and BC is equal to AD, opposite sides are equal and diagonals are unequal, it's a parallelogram. If opposite sides are equal and diagonals are also equal, it's a rectangle. It's very easy to remember, children. See here. If opposite sides are equal, you know, in a rectangle, only opposite sides are equal. We know that. In a rectangle, only opposite sides are equal. We know that. And along with the rectangle, we have parallelogram. So parallelogram and rectangle go hand in hand. Parallelogram, rectangle, because in both the figures, only opposite sides are equal. Then talking about the diagonals, if opposite sides are equal and diagonals unequal, parallelogram. Diagonals equal, rectangle. Then rhombus and square, because in both all the sides are equal. That's a similarity. All sides are equal is a similarity between a rhombus and a square. The similarity between a parallelogram and a rectangle is that only opposite sides are equal. The difference between a parallelogram and rectangle is, in a parallelogram, diagonals are unequal, but in a rectangle, diagonals are equal. And the difference between a rhombus and a square again, in a rhombus, diagonals are unequal, but in a square, diagonals are equal. The similarity is that in both rhombus and square, all the sides are equal. All sides are equal. So if you're given the points P, Q, R, and S, you need to find PQ using the distance formula, find QR, find RS, find PS. Along with this, also find PR and QS. PR and QS. Now you just need to understand the values you get. If all these are equal, that means all the sides are equal. If all these are equal, that means all the sides are equal. That means it should be a rhombus or a square. And along with this, if this is unequal, then it's a rhombus. If this is equal, because PR and QS are the diagonals. If diagonals are equal, it's a square. If they're unequal, it's a rhombus. Yeah, make a note of this, children. And one more thing, sorry to interrupt. If you have to show that the points form a parallelogram, you don't have to check the diagonals. You don't have to check the diagonals. Supposing they give you 4 points and ask you to check if it's a parallelogram. Simply see if opposite sides are equal. If opposite sides are equal, it's a parallelogram. That's it. You don't have to check for the diagonals. Don't check for the diagonals. If simply opposite sides are equal, it's a parallelogram. Only if you have to show it's a rectangle, you should also check the diagonals. Similarly, if you have to show that 4 points form a rhombus, just check if all the sides are equal. You don't have to check for the diagonals. If all sides are equal, it's a rhombus. If you have to show that it's a square, then you have to check for the diagonals. Diagonals also must be equal. Then it's a square. So sometimes you may be asked to, show that the 4 points form one of these. And if it's a rectangle, they'll also ask you to find the area of the rectangle. So area of the rectangle is L into B. L into B, right? So you'd have found everything, A, B, C, D. You'd have found AB, the length AB, and the length of the line segment BC. So simply AB into BC, L into B will give you the area of the rectangle. You'd have found all this, AB, BC, CD, AD. So AB into BC, length into breadth will be the area of the rectangle. Rhombus is half product of diagonals. Area of a rhombus, A, B, C, D, half into AC into BD, half into AC into BD, half into D1 into D2, half into D1 into D2. Square, you know that the area of the square is side into side. So simply AB into BC, side into side. Now parallelogram will be asked only if you had that other section, area of triangle. That section is removed, so I'm not talking about area of parallelogram. Since that section area of triangle is removed, I'm not talking about this one. So if it is area of rectangle, use L into B. Area of rhombus, half D1 into D2. D1 is AC and D2 is BD, or D1 is BD and D2 is AC. Half into product of diagonals. Square will be side into side. Yeah, make a note of all this. Finish writing, children?
Yes,
Yeah. All of you?
Completed, ma'am.
All right. So I'll just show you something. You can take a screenshot of this one and complete this later. So you can see in the second one, in the first one, you can see I have not worked it in detail, but I've just mentioned the lens. You for the first one, children. See, I'm talking about this question 20 AB, where the heading is check if the following points form a quadrilateral. Check if it forms a quadrilateral, and if it forms a quadrilateral, give a special name. Check if it forms a quadrilateral. If it forms, give a special name. So for the first one, okay, for these points, when you work AB, BC, CD, AD, and the diagonals AC and BD, find AB, BC, CD, then AD, these four sides. Along with that, find the diagonals AC and BD. What do you observe? AB and CD. You can just roughly, we don't know if it forms a quadrilateral, but you can mark it like this. We don't know if it forms, but you can just mark so that you don't get confused with the diagonals. So AB is a side, BC is a side, CD side, AD side. And you can see AB and CD are the opposite sides. AB and CD are the opposite sides. They're equal. BC and AD are the opposite sides. BC and AD, they are also equal. So it does form a quadrilateral. Because in a parallelogram, we know that opposite sides are equal. And the because now you have to find the diagonals also, because you'll have to check if it's a quadrilateral. So you will understand why in the next subdivision. The B subdivision, you will understand why we should also find the diagonals. I said you don't have to find the diagonals in this case. I said you don't have to find the diagonals in this case, where when the points form a quadrilateral and you have to show that it's a parallelogram. See, when the question is show that the points form a parallelogram, that means it already forms a quadrilateral. If they give you 4 points and ask you to show that the 4 points form a parallelogram, that means they already form a quadrilateral. You just have to check if it forms a parallelogram. So for that, you just have to see if opposite sides are equal. You're not concerned about the diagonals. So don't find the diagonals there. Again, if they ask you to show that it's a rhombus, it's already a quadrilateral then. They want you to show it's a rhombus. So just find the sides. If all the sides are equal, it's a rhombus. Otherwise, it's a quadrilateral, that's all. It's not a rhombus. Find all the sides. If they're equal, it's a rhombus. So when should you find the diagonals? Only when you have to show that it's a rectangle. If you have to show that it's a rectangle, then you should find the diagonals. Or if you have to show that it's a square, then you'll have to find the diagonals. Only to show that the points form a rectangle or a square, you'll have to also find the diagonals. Because only when diagonals are equal, they're rectangles or squares. Otherwise, to show that it's a parallelogram or to show that it's a rhombus, it's enough if you find the sides. But here in this question, we don't know if a quadrilateral itself is formed. So you have to also find AC and BD. But now this part of the information is not needed for us. You can see that opposite sides are equal. So it's a parallelogram. And in addition to that, diagonals are unequal. So it's just confirming that it's a parallelogram only. It's not a rectangle. When you don't know if the points form a quadrilateral or not, you have to find all the 6 segments. Now, after finding the 6, you realize that opposite sides are equal. So it's a parallelogram. And it's a parallelogram only. It is not a rectangle because we see that the diagonals are not equal. The diagonals are not equal. So it's a parallelogram only. It's not a rectangle. If the diagonals were equal, then it's a rectangle. It's a parallelogram. Furthermore, it's a rectangle. In the next one, using the distance formula, next one meaning this one, AB, BC, CD, AD, AC, and BD. Now here what we observe is the sides, opposite sides are not equal. They're all different. All the sides have different measures. That's also possible. Not that if it's a quadrilateral, opposite sides have to be equal. There can be a quadrilateral with none of the sides equal also. Okay. Now, after finding these 6 line segments, we notice that the sum of 2 of these line segments is equal to the third one. And that is helpful for us because that means 3 points are collinear. When the sum of 2 line segments is equal to the third one, that means some 3 points are collinear. And we know that if a quadrilateral has to be formed, no 3 points must be collinear. If a quadrilateral has to be formed, it's not enough if there are 4 points. Of the 4 points, no 3 points must be collinear. If 3 points are collinear, then no quadrilateral is formed. If 3 points are collinear, no quadrilateral is formed. So that means if the sum of any 2 line segments is equal to the third one, if the sum of any 2 line segments is equal to the third one, that means some 3 points are collinear. If 3 points are collinear, no quadrilateral is formed. So we see that this is 2 root 13. This one is root 13. And here this one is root 13. See, this is 2 root 13. This is root 13. And this is root 13. Which means BC plus AC is equal to AB. BC plus AC is equal to AB. So BC plus A, so that means AB is the longest one. AB is the longest one. And C is like this. AC is root 13. BC is root 13. And this is AB, which is 2 root 13. See, we confirm that they are collinear because if the sum of 2 line segments is equal to the third one, they are collinear. Because if they are not collinear, the sum of 2 line segments will be greater than the third one. When we started, we understood that when 3 points are collinear, no triangle is formed. When 3 points are not collinear, a triangle is formed. And when a triangle is formed, if you add any 2 line segments, it will be greater than the third one. But here we see that when we add 2 line segments, it's equal to the third one. That means they're collinear. So we see that AC plus BC. See, AC, BC, that means C is in the middle. C lies on AB. See here, AC, this is AB, this is BC, this is AC. So we have BC plus AC. There is C which is common, no? That means C is in the middle. B and A. So BC is root 13. AC is also root 13. And AB is 2 root 13. That means these 3 points are collinear. So no quadrilateral is formed. No quadrilateral is formed. Because the points B, C, and A are collinear. So it's very simple. You just have to find these line segments, the lengths of these line segments AB, BC, CD, AD, and the diagonals, so-called diagonals AC and BD. And just observe the values. In the first one, when you observe the values, you see that opposite sides are equal. So it's a parallelogram. Additionally, diagonals are also unequal, so it is a parallelogram. In the second one, you see that the sum of 2 line segments, these 2 is equal to the third one. That means the points are collinear. The points A, C, and B are collinear. So if 3 points are collinear, of the 4 points and 3 points are collinear, no quadrilateral is formed. Yeah, please take a picture of this one, children. Okay, I hope it's over. Yeah. Now these questions you'll be working. Take a picture of all these children. In addition to these, I already showed you 4 questions, no? We were given points A, B, and C, and we have to check if the points are collinear or they form a triangle. So that one we have not answered. I said you should find A, B, B, C, and AC, and then if you cannot complete it, we'll do together. I told you that earlier. So you'll have to work from there. You'll have to work from there. And now take a picture of this question, children. So work those 4 and then this one. Take a picture. So here you'll have to show that it's a rectangle. That means you must find the diagonals also. You must find the diagonals also. And then area of the rectangle, L into B. I think I'll just put the questions on WhatsApp. So yeah, you can get started, children. I'm sharing the questions on WhatsApp so you can start working. That's all, I think. Yeah, children. In all, we have 4 plus 3, 7 questions. Please work them. Started working, children. Are you all working?
Yes, ma'am.
Okay, thank you. All right, I think you'll need at least about 20 minutes for that. I'll just come back in 20 minutes, children. Please continue to work. I'll put your mics on mute so that if by mistake somebody's mic is unmuted, it wouldn't disturb the class. So I'm just putting all your mics on, meaning I'm just disabling mic option for all of you. I'll resume it once I return in 15-20 minutes. Yeah, hello children. Tell me for the first one, your values for AB, BC and AC. Yeah, tell me, somebody. Shashank is trying to say something, but I can't hear you, Shashank. Nobody wants to share?
Ma'am,
You're not sure about your answer?
Ma'am, can you hear me now?
Oh, I think, oh, okay. Try now, children. Oh. Yes,
Ma'am, can you
Tanya.
hear me?
Yeah. No. I have to change my device settings. Sorry. Yeah. Yes, Shashank.
Yes, ma'am. AB is root 709 by 5.
Root 709 by 5. Okay, what
Ma'am,
about BC?
AB has
AB
ma'am, I
has
got 3 root 61 by 5.
51 by 5, huh?
3 root 61, ma'am.
Yeah, 3 root
61.
Oh, 61 by 5. Okay, Danya, then for BC?
2 root 61 by 5, ma'am.
Okay, looks correct. And then for AC?
Root 61.
Very good, yes. So you can see that when you add these two, 3 by 5 root 61 plus 2 by 5 root 61 will be root 61 is common. So 3 by 5 plus 2 by 5, which is 5 by 5, 1. So it is root 61. Your answer looks right, Danya. Very good. Yeah. Class, you can check your steps. Yeah, so you can see here after taking the LCM, all of us should get C, irrespective of how you wrote this, meaning whichever order you have taken this one, all of you should get this. So this is what we get. And the denominator, the square root of 25 is 5. So you can see in the next step, I've written 5 and taken the square root only for the numerator. Then you'll have to find the prime factors of 549. 549. So here you should use a test of divisibility. It's not divisible by 2. Then 9 plus 4, 13. 13 plus 5, 18. 18 is divisible by 3. So 549 will be divisible by 3. So 3 ones are 3, 3 8s are 24, and 3 3s are. Again by 3, 3 6 are 18, 3 ones are 3. And 61 is a prime number. So 549 can be written as 3 into 3 into 61. Now from 2 3s, 1 3 out of the square root. So 3 root 61 by 5 or 3 by 5 root 61. In the same way, the second one, you should get this after simplifying. The square root of the denominator 25 is 5. So square root of 244, which is nothing but 2 into 2 into 61. Now from 2 2s, 1 2 comes out of the square root. Root 61 by 5, which is nothing but 2 by 5 root 61. AC is root 61. So we see that AB plus BC, AB plus BC, when you take out root 61 common, you will get 3 by 5 plus 2 by 5 in the bracket, which is 5 by 5, 1. So root 61. And AC is also, see, AB plus BC is root 61. AC is root 61. So clearly AB plus BC is equal to AC. The sum of two segments is equal to the third one. That means the 3 points are collinear. Sashank, can you tell me where I should help you? Or
No,
you...
I found my mistake. I did wrong in the symbols.
Oh, okay, okay. Yeah, you can take a picture of this class. Yeah, for this one, A, B, B, C, and AC.
AB is 3 root
13.
3 root 13, huh?
BC
Okay,
is
BC.
5 by 2 root 13.
9 by 2 root 13, okay.
5 by 2 root 13. 5 by 2.
Oh, okay. 5 by 2 root 13, and then?
AC is 13 by 2. Root 13 by 2.
Oh, root 13 by 2. So that means 1 by 2 root 13. 1 by 2 root 13. Yeah. Yeah, Prajit. Yes, Prajit. And I think Danya announced the answer. So you're right, Prajit. 5 by 2 plus 1 by 2 is 6 by 2, which is 3. 3 root 13. So here also we see that the sum of two segments is equal to the third one. So the 3 points are collinear. Okay. So for AB, it's this one, prime factors. BC, the denominator 4 is a perfect square. So bring it out of the square root. Square root of 4 is 2. So the square root of 325. Prime factors, 5 into 5 into 13. 1, 5 out. So root 13 by 2 or 5 by 2 root 13. AC is this. 4 is a perfect square. So square root of 4 is 2. Root 13 by 2, which is nothing but 1 by 2 root 13. Root 13 by 2 is nothing but 1 by 2 root 13. So BC plus AC, BC plus AC, you can take out root 13 common. So you get 5 by 2 plus 1 by 2, 6 by 2, which is 3 root 13. So BC plus AC is 3 root 13, the sum of these two. And this one is also 3 root 13. AB is 3 root 13. So since BC plus AC is equal to AB, so that means it will be like this. C on BA. Or it can be AB here also. BC AC is equal to AB. That means C lies on AB. Because C is common. BC, AC, C is common. So C will lie on AB or BA. Yeah, this one.
Ma'am, AB is 5, BC is also 5, AC is 10.
10.
Oh, 5, 5, 10. Okay. Oh, yeah. Even I don't have the complete steps for this. So AB, BC, AC. So they are collinear. Yeah, this one, children.
And that I got 5 root 2. AB as 5 root 2. BC as 2 root 13 and AC as root 2.
Yeah, so now when we have, values which are not related, or we cannot do anything with them. Just a second, children. Yeah, children. So now see, in the earlier cases, it was easy to add some two line segments and show that it's equal to the third one. Not always will it be like that, or not always a question will be designed like that for you. So I don't know for this one, but I'm just telling you. Sometimes you have to find the square root of the numbers. It depends on the values you get. Sometimes you'll have to find the square root and then interpret. So in this case, yeah, this is what I have. Were we talking about this one, children?
Yes, ma'am.
Yeah, so check. I don't have the steps completely, but this is what it is. See, I have also tried to give a special name to the triangle in case that question is asked, Check if the following points are collinear or form a triangle is a question. You are not asked to give a special name, but supposing you're asked to give a special name, then you have to work this. So we get root 50, root 52, and root 2. So you need to approximately, because even if you write them as mixed surds, you cannot add and show anything. Even if you write them as mixed surds. Now, what is root 50? 25 twos are, so 5 root 2. And this one is root 52 itself. And this one is root 2. So you cannot, because they're unlike surds, you cannot add two things and show it's equal to the third one. So in cases like this, you have to find the square root. You have to find the square root. 50.0000, this method. 7 sevens are 49 and all this. So this one is 7.07. This is 7.21. And this one, right? 1.414. So 1.41. Find everything up to 1 decimal place or 2 decimal places or 3 decimal places. We'll just have it uniform. Now you can see that when you add any two, when you add these two, it's greater than the third one. If you add these two, you can see that answer is greater than this one. Or if you add these two, you can see that answer is greater than this one. You can check and see that the sum of any two line segments is greater than the third one. Not only one case, we'll have 3 cases here. AB plus BC is some 14 point something, is greater than AC. Then BC plus AC, some 8 point, is greater than AB, which is 7 point. And AC plus AB. Okay, so something like 9 point you'll get. AC plus AB is greater than BC. So it should always be true, not only for AB plus BC is greater than AC, so it forms a triangle. Not like that. The sum of any two line segments should be greater than the third one. So you can see that AB plus BC is greater than AC, BC plus AC is greater than AB, AB plus AC is greater than BC. So since the sum of any two line segments is always greater than the third one, the given points form a triangle. And what kind of triangle it is? It is a right triangle because it satisfies the converse of Pythagoras theorem. It's a right triangle because it satisfies the converse of Pythagoras theorem. So obviously from these values, we can make out that root 52 is the greatest value. Even if you don't find the square root, this is root 2, this is root 50, this is root 52. Obviously, this is the value. This is the line segment which has the greatest length among these three. Since this is root 52, the length of BC is the longest or the greatest. So square that separately. The longest side should always be squared separately. BC square, 52. Now find AB square plus AC square. Find AB square plus AC square. Square the longest side separately. Then find the sum of the squares of the other two sides. Sum of the squares of the other two sides. You know, this is how we check converse of Pythagoras theorem. So root 50 the whole square plus root 2 the whole square, which is 50 plus 2, 52. So you see that AB square plus AC square is equal to BC square. So by the converse of Pythagoras theorem, it's a right triangle. And since BC is the longest side, BC is the longest side, A will be the vertex containing the right angle. A will be the vertex containing the right angle. So the first thing we need to remember is if the values cannot be added, you know, and if you cannot add them and show that it's equal to the third one or check if it's greater than the third one, you have to find the values approximately like this, the decimal values approximately like this. And then you have to check if the sum of any two line segments is, always greater than the third one. And that way show that it's a triangle. And once it's a triangle, if you have to give a special name. So in this case, it's a right triangle because it satisfies the converse of Pythagoras theorem. AB square plus AC square is equal to BC square. So by the converse of Pythagoras theorem, the triangle is a right triangle angle at A because BC is the hypotenuse. So it's right angle at A. This one I have asked you to take a picture, or I think I shared the picture also. No, I didn't. Yeah. Since it's time, children. Yeah, what's the area of the rectangle ABCD?
40 square units.
40 square units.
40. Very good. Please check, children, if you got the same values. Okay. So it's a rectangle because opposite sides are equal and diagonals are also equal. Opposite sides equal and diagonals equal. So it's a rectangle. Yeah. What about the area of the square?
It is not tasked to find the area of the square.
Oh, I'm so sorry. I didn't notice that. Show that the points are the vertices of a square. Okay. So that means all the sides must be equal. So what's the length of each side?
2 root 5.
2 root 5.
Okay. 2 root 5. Correct. Okay. So since we'll have to show it's a square, simply showing all the sides equal is not sufficient. Because you'll have to show that it's a square. Simply showing that all sides equal is not sufficient. Because when all the sides are equal, it can also be a rhombus. You have to show that it's a square. So you have to find the diagonals. All the sides must be equal. Diagonals also must be equal. So it's a square. Yeah.
5
Rhombus.
root
5 root
2. 2 ma. 5 root 2.
Okay. For this one, I have all the sides equal to root 26 units and the diagonals 4 root 2 and 6 root 2. Area half into product of diagonals 24. I don't know, maybe some of you did not have time to finish also, that's fine. Okay, I've shared all the images on WhatsApp also, children, just in case you were not able to take pictures or screenshots. Okay, so today's class was very quiet. So I must thank Prajit, Sashank, Danya. I think Rakshita also earlier. Yeah, and Navya was not so active as usual today. Yeah, the others did not participate. Dileepan, never. Krishmi, you have to fix your mic issues. Florentina, you must participate. Arjun also never. Raja, never. So I'm able to do the online session only with the help of a few active participants. I would like to mention the names again. Danya, Prajit, Sashank, Navya not today, otherwise yes, and Rakshita. All right. Thank you so much, children. All right, children. So that's it for today's session. Thank you so much. You may leave the call. Good night.
Thank you, ma'am.
Thank you, children.
Thank you.
Thank you, ma'am.
Thank you, children. Good night.